welcome everybody to the next session. It's about cloud and cloud native, the evolution and how it all started and where we are today, how we can design applications and what's the future. So my name is Benjamin. You can find me also on Twitter. I work for a consultancy called Codecentric. And I come from Germany, and there I had the pleasure to organize JavaLand, which is a conference in an amusement park, as well as Cloudland. And I also founded and run a JAG and microservices conference. Yes, so feel free to reach out if you ever travel to Germany. I got the opportunity to write an article some time ago about this topic, so it will be linked later. And now let's try to bring in some light into the dark. First of all, I'd like to talk a bit about, briefly about the history. How did the term originate? What does it include? What are the drivers from the industry for cloud native? Why do we need it? Why do we have it? What is the current state of principles, also from different companies and vendors? And how did we do the design of a cloud native application by example? And afterwards, I want to talk very briefly about some toolings and give some more hints. So let's start. Yeah. So in general, there's the industry and then there's the academia world. And when we look at the scientific publications, we will find that there is a lot of different coinings for the term cloud and cloud native. And this is put into contrast to classical distributed systems. So 2006 is a nice year. At that time, Amazon launched S3 buckets for the first time. And in the industry, quite new were like the terms private cloud, hybrid cloud, infrastructure as a code, platform as a service, or software as a service. Then in 2011, there was a publication called the NIST Definition of Cloud Computing. It's basically a glossary. And there is a lot of definitions already, not yet about cloud native applications, but already very deeply about cloud computing. And just later that year, the popularity of the term first arose, cloud native applications in the industry, and it got spread a little bit already into academia. So that there was a paper release called Cloud Native Engineering, and there was already like some explanation about some systematics behind it, like for example, availability and outage tolerances like the CAP theorem, so that you can just achieve two, like you see it in the small picture below. 2015 was the year where when you searched in Google for the first time, a lot of hits were recognized for the term cloud native. At that time, we perceived it as a logical evolution of microservices, which included already containerization. Then there was a very big and maybe the most famous release of a paper, or a famous paper by Kratzke and Quint. And they were giving an overview of 10 years of cloud computing. In the next slides, I want to step a bit into it. What did it already include, and what was part at that time of cloud native? So the most prominent thing that appeared was a definition. So a cloud native application is a distributed, elastic, and horizontal scalable system composed of microservices which isolate state in a minimum of stateful components. The application and each self-contained deployment unit of that application is designed according to cloud-focused design patterns and operated on a self-service elastic platform. So they already took into account many different papers and tried to summarize it, and this was the first definition for cloud native application. They tried to consider several design principles. Maybe you heard about EDR, so like isolated state, distributed in nature, elastic, horizontal scalable, automated management, and loosely coupling. So this is something that is needed for CNA architectures as well. They identified that they need speed, safety, scale, and client diversity. Among them, they defined a lot of different terms. I want to just very briefly go into it. Elasticity, so that you can have like the provisioned systems like distributed so that they can handle all workloads that is coming in. And not just that it's like in that case taking into account every moment that it works, but also like that it's scalable through the load that it's put onto. And besides that, they at that time preferred the style of microservices where you have one service that does one thing well. We have a few more definitions here. For example, when you run it, they already have seen at that time that elastic platforms are coming up, so that you have a distributed system like Kubernetes, Swarm, or OpenShift, where you can run everything. They also took into account that DevOps is a natural fit, so meaning build, test, and run, and all the automation part. And they also realized that there is a softwareization shift, so everything gets automated in the infrastructure and network world. The other things I will go into later in detail at the example. So, what's the drivers from the industry side? So when we look at how the markets evolved, we see that there was a pre-industrial area, and there was a lot, like in the early 90s, there was the key to success for any companies to survive was mastering the art of craftsmanship. Everything was manufactured by hand, basically, and you had local markets at that time with high customization. So the winning factor for any company was like to master this tailor-made systems, right? And later on, when we had the industrialization, we could scale. So we had supply chains already, and there was a lot of workers that did the same step over and over again. And the key to success in that unsaturated market was to produce as cost efficiently as possible. So everybody knows when Model T came out, there was not a lot of cars in the market, so it's very easy to conquer the market, and you just need to look at your cost factors. These days, we are in the age of post-industrialism, so there's already a saturation in the markets, and we need to find the right fit in a really short time. This means that we now need to produce very fast, but also take into account that customization process and fulfill the demands for customers as quickly as possible. And that demand is driving the speed of our industry as well. So drivers are these days the cycle times, adaptability, flexibility, and the resilience of everything that we deliver. In the past, it has been a lot different, so cost efficiency and scalability was much more important. When we go and see software engineering layered on top of the whole industry, we see that the things are now changing. it's getting more and more complex. You see that scale horizontally and vertically. You see what's the need for IT and how is it growing. So yeah, of course, we are in a software world, an IT world. So the need and like support is growing, but also like in this business nervous systems, we get a lot more complexity than we had in the past. Software engineering, we need to take that into account, was more invented around the 1780s. So there was a lot of different design principles and decisions that were made at the time that might not align to how we need to like support the markets. So in the bathtub curve, we need to know that decisions that maybe have been done on some programming languages and how they were designed, and maybe also like TDD and all that things, they have been made in a time that is quite some time ago, where everything was quite complicated already, but not as complex as we are today. So some best practices for that art could be counterproductive for going into cloud native world. So just to sum up, here in this chapter, like post-industrialism is about these days lean startup, lean enterprise, continuous design. So go out to the customers with prototypes, get early feedback, have Google design sprints being made, and try to adapt to these highly dynamic markets. On the other hand, we have like digitization and disruption. So disruption means that we came out with new technologies and we blow away all the competition by, for example, like Uber did with Taxi World, right? So this is the goals that we try to align to with cloud native. For every organization, this means there was a shift, of course. So we had traditional feature teams, where like business capabilities were solved. Then we handed it over to ops land, and we tried to fulfill this like in longer cycle terms, where like everybody was specialist, and there was not so many generalists that can handle all the workload, but more teams that needed like more like a waterfall of like code that went through each department until it was live and released. Then came the DevOps organization shift. So now we are focusing on building up cross-functional teams, so that within a team you have all the capabilities, front end, back end, and operations, so that you can run everything on a platform 24/7 and also like maintain it. Yeah, what are the implications? So when we look at that, so we might start in the middle. So we have DevOps now, and the people now need to do continuous improvement. They need to be curious for that. Every engineer needs to find its own T-shape to fit into a cross-functional team. And for that reason, we have autonomy within the teams. So we try to decouple business logic between the teams. And furthermore, the control should not be centralized as before, but decentralized. And each team should focus just on the outcome, at best already like looking at the market. This means as well that we still need again this craftsmanship and mastery to have the capabilities for building up these microservices landscapes in a heterogeneous way, and also fulfill continuous delivery on the side. So it's a lot of things, but we have the new tools, cloud and containers, and operations. So what does the industry think about that? what did it came up with? So in the beginning, Heroku, these days not present anymore, came up with the first idea of a 12-factor app. So to have one code base, to have dependencies, and how configuration is handled, how it's stored. And when they built the platform, they derived all these like factors from it, and we could align to it for quite some time. These days, we figured out that there's already a bit more to do. So there's a new book out, like Beyond, what was coming out at 2016, Beyond the 12-factor app, and there it was already like stated that besides all the things, we also need telemetry. And when we look back now in the past 1 or 2 years, was at conferences, talks, for example, about open telemetry have become more and more popular, and we try to include all the things that have been stated here already in 2016. Another like nice catalog where we can align to is the Microservices Patterns website or book from Chris Richardson, where it's also like you can find a really vast majority already, like for all different kind of scenarios when you have like landscapes with little services. Later I will outline how we perceived it and how we moved on in that direction. When we look at the distribution, a nice summary on like how we handle containers and what does solid mean was given out by Redham. So Bilgin was summarizing it up. So like that single concern that we need within a container, and that every container has high observability, that you have endpoints for everything, for readiness, for health checks, tracing, logs, liveness, and metrics. So you can find that here. Then there's a few more nice principles that have been summarized. For example, the ESA principles, where we look also at self-contained systems. So there's 2 web pages on that. And from methodology perspective, 2018 was more or less a year where like event storming was pushed through and through, and I will outline how it worked for us. But still, some fundamentals, they have been quite old. So in domain-driven design, when you have several services that want to connect to each other, you use strategic design, and within a service, use tactical design tools. Now let's try to look at that. So imagine that you have a certain domain and you want to conquer it, and you have some developers and engineers already, and they need to work on this together. Probably they know each other already, maybe not. And you also have expert like product owners. So what we do here is like within that very lightweight approach of event storming coined by Alberto Brandolini, we put them all in a room, right, on a wall that is endlessly long, maybe 5 to 10 meters, and we hand out Post-its as a facilitator to them. And I did this several times within our company context and also for clients, and it works very well. So I just ask like to write down like for 10 minutes, for example, very briefly, everything that comes to your mind in a past tense as an event on, for example, orange sticky notes. And after that time is over, you see that there are some people that have a lot of sticky notes, some have just a few. And then I usually pull out persons that have just like a few sticky notes, and I let them put it on the wall. So you have a process with a timeline from left to right. And we start with just like a few Post-its, and then the next person comes in and puts Post-its up. And in the process, you can invite everybody to put up Post-its. and we will then see through the communication here that there will a structure emerge, and you already have like a nice overview of what's going on within your system. Very important is here the domain experts, because later on we want to figure out the language that we use as well here, that it's within the business context. To form an ubiquitous language, we put up next to the board something like a glossary, and we now want to figure out within that system what words are used already, what were not used, and what looks similar, to reduce it to a unique language, right? And throw out duplications that have just a different wording for the same thing. When we have done that step, we go on with another iteration, and we want to think about how did all the events appear and what did lead to them. So next thing is we model commands. So everybody goes back to their chair or standing, depending on how the situation is, or like virtual whiteboards is of course like different, but also working, and putting out like in present tense ideas how every event happened, right? So for example, when you have an event like product is shown in cart, how did it appear in the shopping cart when you're in e-commerce domain? So it could be that you searched on it on the landing page and just clicked on it, or that you maybe run a product detail page, and everything could be a different command that might lead to a similar event. Yeah, so we go on, and usually there's some pairing, and sometimes also when an event might trigger or a command might trigger one event, it could also be that there's several events. So when a product is put into a cart, it could also be shown in a mini cart, or there could be already some calculations, for example, that the stock level needs to go down, and this all needs to be adapted. When we have that ready, we think about what's the thing that is interacted with. So we try to figure out what's the aggregate or the entity that we want to use. And what's now the interesting part is that, for example, when we have a product in an e-commerce world, and it's like an e-commerce system, typical web shop, like it's changing over time. So on the left, when we start the process, the product on the landing page just has one or two attributes. Maybe it's like a picture, price, and title, and maybe already a reduced price. But when we go deeper on the product detail page, there might be colors and different variations. There might be labels, or like warranty, confirmation, and different things that are attached to that same aggregate or entity. And in the checkout later on, it might be interesting where the product is stored, in which warehouse, or how do we retrieve it so that we can send it out to the customer. And so it's changing over time, even though it's still like feeling like the same entity. And this gives us an idea where the borders might be, so we can look at each domain model separately, and if it's having a change in its like attributes, we figure out that we are going over a certain step. And you can then briefly outline also on the board that here is a change, and cluster your whole process so that you see where the bounded context later on might derive. Within each bounded context here, you may find several microservices or you may find just one service depending how you cluster it and other steps. So is there any questions concerning to this process at the moment? Okay, good. So then next step is we think about what's each context about, and we can label it. For example, the third step here could be the checkout process. First step could be like landing page. Middle one could be product detail page, and in the end it's more like shipping confirmation, or depends where you want to put it, or it's like completely different thing. So this is how you can evolve very easily a structure that might be a natural fit for having like small services. And it's creating different narratives. So what you do next within the workshop group is you ask all product owners about use cases. So what can you think of? How is your product used in production? So maybe somebody could call, or there is a merchant that could also add stuff for a customer to a product. And it's not just the visitor who is like using it. And there might be multiple storytellings, but there's still a common language for everyone. And now you can figure out if you missed some spots within your domain where you need to like put together more things, or where it's like necessary to maybe go for another iteration, maybe start once more with the blue post-its and with the orange post-its, blue post-its, and yellow post-its, and to figure out what's missing, right? When we shrink down all these like bounded contexts, we can come up with a nice architecture, and then it depends how you want to structure your landscape. So with microservices, you could go for an approach where you have like what we did, like front-end services in a horizontal that were like talking to back-end services that just exposed APIs, or you could go for self-contained systems where you are breaking through like the whole, for example, when it's a web application website, so maybe each page is a different service. So that's how, for example, we in Germany do it for our clone of LinkedIn. Or if you do it like Netflix way, where you have like different parts that are exposed from the website, and they are like loaded independently. Of course, you might have still some core services, for example, API proxy or handling authentication, that are like maybe a bit excluded because of overlapping capabilities. So the next thing that you want to address is the communication between the services, and think about it as there being an upstream system that is talking to a downstream system, and it gets from a request back a model, like a domain model. And there's different like categorizations. So we have the upstream patterns, we have the in-between patterns, and we have the downstream patterns. And we look at the upstream patterns, then it's like that you have, for example, the open host service where the system exposes like endpoints like SOAP or REST, and the other systems, they just connect to it. And this is very useful when you think about the architecture of your cloud native application in terms of how is the connection between each service. Is it one-to-many or is it one-to-one? What do you want to achieve? In this case, open host service is always helpful when you have a one-to-many relationship, and you are the driver within your team for your bounded context and can define how the world should perceive you. Here is an implementation example. I think everybody has seen some REST controllers. So I won't go into detail. Here is realized with Spring. A substitute or like a subtype of the open host service, as it is coined also in the books by Von Vernon, is the event publisher. And here we see that we just like give away a message. So the point is here that it's more asynchronous, and some behavior still stays the same, but we use messaging. So this is the event publisher. And very important here is that when you publish the message to a broker, of course, that you have the right wording and keys included. And we can see here the domain model, which is the object that is interacted with. Maybe it's an email, mail. And then we have the term, what's happening. So we write it down in the past. And just to be sure, because in the English language, sometimes there's overlap between present and past tense, we note event, and then we have a header for our message and can include next to it the payload that we want to give out to our landscape. Here is another example where we see that it's going often in the CRUD world. So you have a created event and a deleted event, and you were sending out like images. Another pattern that you could use to communicate between the services is customer and supplier. And here's the interesting part, that the downstream system now can, as a customer, define what it wants to get back from another service. So you get incoming requests, and the team that is maintaining the upstream system needs to fulfill everything that the downstream system needs. And sometimes there might be negotiations, so they have a veto right and say, no, we do not want to implement another endpoint just for your needs because we have a similar one, please use this one. But this is very common within a lot of microservice landscapes. And what we use in that regard is consumer driven contracts. For example, we realized it with Pact, and the good part about it is that you have one contract broker in your system, and you just need to include a few libraries, and then you are good to go. And in that regard, when another team has a new sprint and they want to just work on that API, they already get a test case where they can implement against. So it is very easy for them to fulfill the business requirements that might be asked by another team. One system or one other type of connection is the conformist. So here the downstream system just needs to confirm to what's the upstream system saying. So there is no translation between the systems, so the domain model stays the same, and here is no veto rights, and you can just implement, you just need to implement as a conformist what's been given to you. This is, for example, or where I see this pattern appearing is when you have, I think this is the event library. So we want to have a certain layout of our business events, how telemetric data or business data is sent out, and therefore we can include it in our system directly, and so everything looks kind of similar. Here's, for example, side events where you could add different like subcategories. If it's a bit more complex, for example, you have third-party systems that you integrate, and they use a similar wording that you use in your system. For example, for the stock level, and you have your own shop system, and you are also adapting to maybe the Google Shop API or like Amazon, and they also might have stock levels. And because you are expert in your domain, you have probably 5 or 6 different types of stock levels, but they just use like 2 or 3 of them. And therefore, you need an anti-corruption layer, so the domain models are changing, the external and the internal one. And here, you just, for example, have an enum where you just adapt here the shop level, the availability, stock levels, so that you have a nice mapping. Another thing could be shared kernel, which is very important. So between 2 systems, you have a library that you want to use or a database. And I think now comes my message example. I'm sorry, I messed it up a bit. Yes, but here you can see how we wanted our messages to appear and define a certain payload. Shared kernel usually can be, for example, a library that you always include here, for example, with Gradle, so that every service can use it. The next thing that might be of importance is that a service can define and drive what terms are used in the ubiquitous language of your system, and we call this published language. So we can give out like the identifiers that you want to use for commerce systems like IAN, UPC, ISBN, or similar things. 2 systems can also like totally be not connected, and they just go separate ways. Yeah, so let's see. What's there for tooling? So now we have seen how we model our systems and how we can align them so that they're ready for cloud architectures. And maybe we can also see that we do not go like Conway's law way, but reverse Conway's law. So we define our complete architecture of each service up front. And later on, we can align the team structures to how our services and our bounded contexts are like created. So if we consider this and consider the context map patterns, then we can make sure that like the communication between the team is really reduced to a minimum and be as efficient as it can be. But cloud native is just a bit more than just doing microservices. It's also about DevOps, continuous delivery, and containers. And yeah, I want to just like go a bit briefly and like how a pipeline looks like. So there's a lot of tools these days out, and a typical like brief overview of most pipelines is like you need a build stage where you run your unit tests, your integration tests, and there you can build your first Docker images, for example, for each service, and then you can go to the next stage where you have an integration, not just a single service that is tested and checked, but also like different systems in coherence. And in this acceptance stage, we have now different toolings from cloud providers. For example, the Google Cloud Engine can spin up a Kubernetes clusters instantly so that we can install all images from all the services that are connected to the system that is changed, and also deploy the system that is changed, and to see the interaction between them. And on that stage, we try to run the API tests, the regression tests that are going through our whole system, to figure out if anything is broken. And afterwards, we can tear down our cluster very easily. And also, if there's some things that are not working, it's very easy to connect for everybody in a cloud environment. So this is where cloud-native technologies have improved a lot in comparison, for example, to private clouds where you needed in the past to spin up like virtual machines, VMware clusters, or similar things. In a pre-production stage, we already have like test data, might be just one system. You run smoke tests on it, have also regression test suite. And if there's something not working, you can escalate it to community of practice. And you can also have a log towards production stage, but usually everything is like deployed very quickly. On production, you can think about having also a smoke test suite and have everything live. So in the environment where I've been working, we had like 8 teams in the end, and each team could release like 50 times per sprint to production, so this is really nice. And the underlying layout of the pipeline in abstract was similar to what you see here. So about the tooling, what has been there now in the industry. So in 2015, the Cloud Native Computing Foundation has been founded, and there is a lot of players in it, over 100,000 members. And their goal is now to standardize all this like container technologies and toolings that we can use for deploying our microservice systems. The definition that they gave out is like they want to empower each organization to build like this runnable and scalable applications for every environment that is possible, public, private, or hybrid. And no matter if you have like service meshes in the background or microservice or any immutable infrastructure, should help or should exemplify this approach. I think there is like, maybe there's a word missing. Yeah. So the goal that they agreed upon is like to align with all that drivers that we had from Taylorism and to foster state-of-the-art patterns and state-of-the-art technology to make it possible for us to deploy as quickly as possible whenever we need, and also like avoiding vendor login. Often it's possible, sometimes not, but this is at least what they align to. There's also some more definitions, so this was also like, just that you know, the agreed upon also like definition where they want to go and what for them cloud native is. And there's a few more derived definitions from Netflix, Pivotal, and also Red Hat. They have a few more. And when you are like starting out, there's like different things what you can do. You can, if you have a green field or brown field that makes it viable to start directly with like this modeling approach, then it's cool. But on the other hand, if you have like more like a monolithic architecture, you could also try to follow the cloud native trail map, which means that you start with containerization, then implement for your client CI/CD, and after that go on with orchestration and layer by layer step up the whole game that is needed. And just at step 8, you will then start with streaming or messaging and implementing more distribution within your system. Toolings, maybe you've seen the cloud native landscape, so it is really nice overview that you can have a look at all the time, also interesting for clients. And just that, you know, like there's like different types of projects. So we have graduated projects that are really like recommended for everyone, that you can use without any doubt. Very popular choices are, for example, Prometheus or Jaeger for tracing, Helm charts, and all that nice things to make life easier. Then there are some emerging projects that are called incubating. There it is like depends on how far you want to lean towards bleeding edge. So for maybe client projects, maybe not so much, but for internal projects, of course, you can use them, or depending on your expertise, have a look. So for me, business and IT are the same coin, or are on the same side of the same coin. Yeah, and they are now one piece, and on the other side of the coin, there's the market where we want to adapt to. Generally, I think like not every company now needs to become a software company. So yeah, software is eating the world by Mike Anderson is to a certain degree true, but like not for everyone. So there might be companies that have, through cloud native technologies or by developing them, the capabilities to disrupt huge markets, but some are just like industries that will change over time with all that nice new tools, and they will just benefit from having this quicker adoption, but will probably stay the same as a business. For example, when you look at on-site conference businesses, we can enhance it maybe with like cool platforms in the back end where we stream live to and have it scalable. But the general business model of like people coming and networking might stay the same. Yeah. So this is like what we perceived like in the past now when we look back, how IT has changed, how we have now DevOps or even DevSecOps in a lot of organizations, and how we can work in such environments. So here is a link to the slides. So I can recommend, if you want to go deeper into like principles, for example, everything is like linked, so you can retrieve a lot of information there. And I wrote down an article, but unfortunately it's German, in a magazine. So if you want to get that, it's also possible. So thanks for your attention for now. And I'm happy to answer questions or get feedback or ideas. I mean, it's a very like broad overview talk. Not sure like who could get something out of it. It's more like putting it into a bigger picture and a broader perspective. Thank you very much.